All right, so welcome to Madmongers. So tonight I'm going to talk a little bit about Amazon Web Services. Welcome.
Lots of people know.
Yeah. So tonight I'm going to talk a little bit about Amazon Web Services, and specifically about two of them, SES and SNS. SES is Simple Email Service. SNS is Simple Notification Service. How many here, raise a show of hands or whatever, have actually used any Amazon Web Services of any kind? Really? So I'm the only one?
Maybe a little bit. You mean
I've logged
participated in them? Used other people's?
You used the actual, so if you don't know what an Amazon Web Service is, that would be the first clue. But yeah, Amazon, if you, meaning you have actually used them as a developer.
I think I've tried backing up files to it.
You tried backing up files to S3?
Yeah.
Okay.
A while ago.
Okay. Cool.
At a virtual machine for a while.
Yeah. S3 is probably the thing that people use most because it's just like unlimited virtual storage on the web. And then of course there's EC2, which is their virtual servers kind of thing. So that's probably the second most used thing. The two that I'm going to talk about tonight are probably things that most of you or lots of people have not used, because unless you have a specific use case, they're not all that useful. But if you do have this specific use case, they are ridiculously useful. So anyway, my particular problem was that I have 70,000 customers, and I need to send a newsletter to a little over half of them that have signed up for the newsletter. So we have like 45,000 people that have signed up for a newsletter. And we started asking whether or not they wanted to be signed up for a newsletter like 2 years ago or so, and didn't really pay any attention. And then we took a look, and holy crap, there are 45,000 people signed up for this. Maybe we should send out a newsletter. So we looked into, how could we solve this problem? Probably the easiest way is to not solve this problem, which is to use something that already exists. Constant Contact, MailChimp, Sendy, or a dozen other things that are already out there that you can use. So we looked into that, and we ultimately decided against using any of those because they weren't directly integrated with our system. We didn't want to create another manual process of having to import and export users from that system or from our system into their system and back, because if they unsubscribe in their system, now we have to find a way to synchronize whether they unsubscribe from their system or our system, and all that gets kind of complicated. And most of these services, with the exception of Sendy, are relatively expensive compared to Amazon. Like we're talking $100 to $1. So for every dollar I spend on Amazon, I'd spend at least 100 on MailChimp. That sort of level of expense. Not like a huge expense, but I mean that wasn't the primary concern, but it's one of the concerns. The biggest concern was the integration. A lot of these have really old school, crappy ways of integrating also. It's like CSV file imports and stuff, not actual web services. So that was another problem. So anyway, we decided to build our own, and there's lots of other reasons that aren't really relevant to this conversation that we also decided to go and build our own. But so we decided to build our own on top of Amazon Web Services. We already use AWS for a lot of different things, so it was kind of natural to look there to see what they have to offer. So AWS is a series of building blocks that you can use to build internet scale applications. So if you can get servers, you can get file storage, you can get email, you can get messaging, you can get workflow systems and queues. They have CDNs, DNS routing, all kinds of crazy stuff that they do. So I think there's like 60 services in all that they provide, all these different little building blocks. And they keep adding more all the time. So the ones, basically how it works, Amazon Web Services, it's a pre-built and managed cloud hosting infrastructure. So it's all stuff that they build, and then you simply make use of it. And it's built to be carrier grade or above, basically internet scale. It's built to be hundreds of thousands or millions of users simultaneously. It's also built to be fault tolerant, so you can, not that it won't go down, but it's got so many different pieces of redundancy that you can use that if one piece goes down, it doesn't matter. It's got servers, databases, search indexes, all that kind of stuff that I already mentioned. And another thing that's interesting about it is that it's all based on hourly pricing. So you only pay for what you consume. If I need a server for 1 hour, I can literally start one up and pay for just that hour. I can do that without a human. In fact, I can use an API to fire up a server, load all the software on it, do whatever it is I need to do, and then shut it down without human intervention. And I only pay for that 1 hour of usage. That's pretty impressive. And we use all that kind of functionality on our own site. But we weren't using these other services that I'm about to tell you about. One thing about AWS is if you have dedicated hardware that you are co-locating at a hosting company, like here in town there's, what is it called? It used to be called Burby, but now it's called CDW. There you go. So you could, if you throw up hardware at a dedicated hosting provider like that, it's going to be cheaper for sure than using Amazon. What you get from using Amazon is ridiculous redundancy, ridiculous management, and flexibility. So, like if you have a server go down, if something dies, you can instantly fire up another server. And so you don't have to worry about those kinds of things. If you put your own hardware somewhere, you have to keep redundant hardware there or be down while the redundant hardware comes in or whatever. So anyway, that's what AWS gets you. So the two that we're talking about tonight are simple email service and simple notification service. We'll start with simple email service. It's basically an outbound only email sending service. So if you need to send a lot of emails, this will do it. And you might think, well, I already have a mail server. I could just send it through that. But no, you can't. When you want to send 45,000 emails, that will, A, really screw up your mail server, and B, unless you unless it's designed to be a high performance mail server, that will take days for it to actually process those and get them out the door. And on top of that, there are all kinds of there's all kinds of implications with bounce processing, which we'll get into, that your normal mail server cannot handle. So anyway, so no, you cannot send 45,000 emails through your normal server. So this is great for if you have a website where you need to send out account emails, receipts, newsletters, reports, forum subscriptions, anything where you've got lots of users and there's lots of email being generated and being sent out all the time. So there are some sites, for example, there's some forum hosting sites I know of that send 200,000 emails a day just from forum subscription notifications, essentially. So those are the kinds of things where this sort of service is amazing. There are some video games I know of that also have that kind of thing where, you're sending receipts, you're sending password, I forgot my password type things, you're sending, you're being attacked, any of that kind of stuff. There's tens of thousands of emails being generated every single day out of that video game, and so that's another type of use case for this. You can send emails via SMTP or web services, so it gives you some flexibility there about how you're going to interact with it. There are a bunch of competitors for this. SendGrid, MailJet, Mandrill are a few, but there's even more than that. And these are all, like Mandrill is actually the back end that runs MailChimp. So we talked about MailChimp earlier. That's a newsletter sending service. MailChimp is built on top of Mandrill. And so MailChimp has just exported Mandrill as a series of web services so that people could make use of that infrastructure since they already had it anyway. That's a bit like what Amazon has done. They built a lot of this stuff for their own needs, and then they export it so that other people can use it and they can charge an hourly fee or whatever. The cost of simple email service is somewhat, depending on how much volume you send, anywhere between 2 and 12 cents per gigabyte of email, which is
It's ridiculously cheap.
which is basically nothing. Yeah. Unless you're sending out a lot of attachments or something where it's big files, you can send thousands of email for $1, or I mean millions of email. I'm sorry, millions of emails for $1, which is like, yeah. Anyway, so this is what their dashboard system. I thought I'd take you through kind of what it looks like when you're using it. So there's an API that you can either use from a command line interface or through a series of web services, or the API, they've built a little front end on the API called the Amazon Web Services Console. And this is the dashboard, the console for SES. So it kind of shows you, how much of a quota you've used, how fast you're allowed to send emails, some of the statistics of, what it was that you've been sending recently, that sort of thing. You can go in and set up credentials for being able to access it via SMTP or web services. So you can set, you can get little username, password, that sort of thing. And of course, if you're going to be sending email through them, they want you to verify that you actually own that email address. So you're not like sending spam out on behalf of Steve, for example. You fill out this little form. They send you an email. You have to click on a link to verify that you actually own that email, that sort of thing. And then they'll allow you to send from it. And then you can also set up stuff that should happen. Like every time you send an email through there, should it send a message to something to say that email was sent? It could do a web services call, or it could do an SMS call, or whatever. There's all kinds of things. Anyway, so there's lots of little things you can configure in here, but that's the base. So on CPAN, there are 3 modules alone that will allow you to send email through this service, through their web services API. I've not used any of these. That's not true. I've used AWS CLI Wrapper, but not for sending email. AWS CLI Wrapper actually just is a Perl wrapper around their C command line tool. So basically, you interface via Perl, and then it shells out to a command line program to do the actual thing, whatever it is. So anyway, but I don't know why you would do any of those, because sending via SMTP is something you probably already know how to do, and it's relatively simple to do. So in case you have not a clue how to send via SMTP via Perl, this is my preferred way. There are some ways that are easier but less robust. This is my preferred way of doing it. I use Email Mime Kit to generate an email, a MIME compliant email, so that way it'll have all the proper headers and wrappers and all that kind of stuff in it. Then I use the email sender transport SMTP to actually generate a transport layer. You don't have to do this. You can actually, there are shortcuts to get around this, but I wanted to configure it with SSL and SASL, and doing that requires you to actually create the object up front. So I'm just placing in the information here that Amazon is giving me to connect to this. And then ultimately you just send it. So no big deal. Any questions on that?
So this is per user? And spam to?
Yes, there would be one email that I would spam to. Yes, one of those per user that I'm going to send a message out to. So if I need to send it 45,000 times, I will at least need to do that last piece. If it's not personalized, I would at least need to do that last call 45,000 times. So I don't need to recreate the transport every time. I wouldn't necessarily need to recreate the message every time unless it's going to be personalized, and in my case it is personalized. And most most of the time when you're doing like kind of a newsletter type function, you're going to personalize it. Even if you're not saying hello Steve, you're still personalizing it because you're going to put in like unsubscribe links, for example, that will be unique for the per user. At least if you're following the CAN spam laws, which you should. Anyway, yeah. So that seems simple enough to just send an email. I could just go ahead and write a loop that would send it 45,000 times, but it's not even close to that simple. Because you have to deal with this thing called bounce processing. So bounce processing deals with dead email addresses, mailboxes that are full, people marking your messages as spam, out of office messages, all the crap that you could get back if things don't go according to plan. And there are more, those are just the common ones. In addition, like I said, you can also deal with receipt processing, which is you have actually successfully sent the mail and they accepted it. So some systems want to know that it went through and therefore will deal with the receipt processing in addition to bounce processing. And some systems can go even crazy far, which is very unreliable via SMTP, which is read processing. So you can actually see if they opened the message and read it. It doesn't work via SMTP. People that are doing it successfully are doing it via embedding some HTML into the message that loads a URL somewhere.
But any decent client blocks is Outlook is the only, well, I guess a lot of people use Outlook, but Outlook is the only insecure.
Okay. So, where were we? So yeah, we have to deal with bounce processing. And then, if you don't deal with bounce processing, you are a spammer. And it's very, very easy to become a spammer, even if you're not spamming anyone. So like you were saying, I'm sending out 45,000 spam messages. But these are actually people that requested to get these messages. So theoretically, they want them. And I say theoretically because even though they requested them, it is still theoretical that they want them. Here's why. This is what it takes to be classified a spammer. For every 100 emails you sent, or if we look at that as percentages, 5% of them bounce for any reason. That will give you spammer classification in like Gmail, for example. They will start thinking you are a spammer if 5% of your emails. So if I spend 45,000 emails, and let's say people's email addresses have changed since they said they wanted that email, it's very easy for me to become a spammer according to Google, or lots of other mail services too. So it's even worse than that though for marked spam. If somebody actually marks it spam, 0.1% will create me. It will
So like
label
if
me
a
as spam.
user clicks spam on it?
Yep. 0.1% of the emails that I send could label me as spam.
That's only 1 in 1,000.
If 45 out of 45,000 mark me as a spam, yeah,
It's pretty high standard.
it's very high standard, and that's kind of an industry average. It's not like there's no laws or rules. It's just kind of the general rule of thumb, 0.1%. So
a lot of people are afraid to click unsubscribe because they're told not to click links in emails.
right,
So they click mark as spam in hopes that that just solves the problem.
right.
How do you get around that?
You don't. But I'm going to show you a solution that helps get around that.
Okay.
But you can't get around the fact that people are afraid to click on unsubscribe. There's nothing you can do about that. What you can do is treat it properly when they do mark it as spam. It may still be too late for you by the time that happens, based on, again, 45. It takes 45 out of 45,000. You're done, right?
I'm sure this is what you're going to talk about, but can you tell that a person marked,
Yes.
an individual person
Yes.
marked an individual emails?
Yes.
Okay.
So
Is there any going back once you get labeled a spammer?
it's tough. It's tough to get back.
Does Amazon punish you for it? Or does
Amazon also punishes you for it, but they're
How
not.
does Amazon know?
because they get complaints back from electronically. They get complaints back from the major email providers
Right.
about emails that were sent, and it's tracked by email ID. There's a unique ID in every email,
Right.
so it's tracked by that unique ID that it comes back to me that was a complaint. So like Yahoo Mail and Google Mail and Outlook.com and all those kinds of things actually will report back to Amazon that they did that. So anyway, so this is what my statistics look like for the last time I sent the newsletter.
You're a spammer.
That's right. 45,000 messages, and keep in mind that it's roughly 0.12% marked me as a spammer, right?
I'd say 14.
Whatever, point something, somewhere between 0.1 and 0.15
Yeah.
marked me as a spammer. And these are people who asked for me to send this email. I did not send it to people that don't want this email. So
Is the box checked by default or not?
no, it's unchecked by default. So anyway, in addition, 8% were bounced for one reason or another. And this is only permanent bounces that it's counting here. So not like mailbox full or out of office messages. These are user does not exist or some other critical error occurred.
It's a 500 level error.
Yeah, exactly.
So you guys labeled as a spammer. The spam police came and locked your business up.
Well, not quite that bad, but yes, I mean, you have to work through it. And anyway, and I was doing everything correctly.
Yeah.
So that's how hard it is. So this is where simple notification service comes in. Simple notification service is a push notification service. It can push to lots of different endpoints. So it's great for updating mobile clients. You can push out to, like an Android device or an iOS device or whatever. You can trigger tasks. You could, for example, one of the endpoints could be an HTTP or HTTPS service where you're actually doing a post of a JSON blob to that service to, notify it to trigger some kind of a task. You could notify staff via email or SMS. You can send out emails or SMS via this system. There's lots of different things you can do with simple notification. The cost depends on the output method. Like SMS, for example, is very expensive. It's like, I want to say it's like $30 per 100 SMSs or something like that. So that would be
Not that expensive for
it's not expensive for SMS, but relative to the other ones.
Just everything else,
Yeah.
yeah.
So for example, an HTTP method is about $1 per million requests, per million messages that you send. So actually it's 60 cents per million, I think is what it is. So, and most of them are kind of in that range, but some of them, are more expensive than others, depending on the endpoint type. So competitors for this are like PubNub and Pusher, which I've talked about here before. There are others, of course, that do this. So go ahead and look at those guys. The most common use case, in fact, those work better in most use cases, I find. I like Pusher better for almost everything than Amazon SNS. But where SNS really shines is when you want to have all Amazon stuff communicate with you. For example, if you run a database server at Amazon, it can push statistics about how that database is doing via SNS out to your monitoring systems, right? If you are doing email, it can push bounce and receipt notifications out to you via SNS. So that's where it's really a killer app. It's because it's all tied into all of Amazon's stuff everywhere. So anything you want to be notified about that's in Amazon's world is very simple to configure through this. And that's the use case I use it for. This is, for example, I have two topics set up. One is for database swap, which is not what it sounds like. It notifies me. So I have multiple databases that fail over on each other. So anytime a transition occurs, this sends out an SMS SNS message to some web services to let that know that that's happened. It's transparent to the users. They would never notice, but I want to keep track of it. So I have one set up for that, and I also have one set up for SES. So this is what a message looks like if you were to get an SNS message. Let's go through it and make it a little less ugly. You get a type. There are basically two types. Well, there's three types, but the third type nobody deals with. The first type is a subscription message saying, hey, you set up this endpoint, can you actually process it? The most common type is the notification type, that, hey, here's something that happened. And the last one is a cancellation message, which nobody deals with because by that point you've already undeployed the code. So it doesn't matter whether it was successfully received the cancellation message. So unless you're automatically creating and destroying SNS endpoints, which then you might care about cancellation. Anyway, so then the important stuff is in the message field, and then you have, to make sure that this is actually coming from Amazon, not from some third party, you're going to want to verify that it was signed properly, which is actually kind of a trick because their documentation for how to verify a signature leaves out a few steps. Like it'll say, step 8, use the decryption method from step 3 to do this again, or encryption method to do this again. But in step 3 it didn't mention a encryption method, so which encryption method are we talking about here? So you have to kind of reverse engineer it to figure that out. And luckily I did that for you and created AWS SNS Verify so that it will do this. And then you don't have to deal with that on your own. So you basically get the body of a message, the HTTP post, however you're doing that. So if you were doing it from Dancer, for example, you'd call request body. And then you pass that into AWS SNS Verify and call verify on that. And it will go out and do the things that it's supposed to do. And if it checks out, you can return a message. It'll decode the JSON for you and give you back a nice little Perl hash with that stuff in it from the previous slide. So pretty simple, pretty straightforward. So this is what a bounce message looks like. This is the JSON blob that would get posted if you bounced. And you can see that the JSON, in the message, there is a JSON encoded string inside the JSON method. Note that this is not one contiguous JSON structure, so if you decode the outer message, the inner message is still a string containing JSON, okay, because it is encoded. So you have to decode it a second time to get the message out of it. So assuming you did that, this is what the message actually looks like that's inside the message field. And so we can see who originally sent the message, for example. And we can see who were we sending it to. Note that there's an array there because it could be multiple people that you sent it to. Now, this is where it can start to get tricky, because if you send a message to multiple people at the same time and one of them clicks on mark spam, you may not know who marked it spam. So anyway, there is sometimes you can make it work, because this will return back who the remote server was, or who what the remote server knows this user as. So if that is the same as the message you sent it to, like if it didn't go to an alias account, for example, then you could match it back up to the original person and work it out, but it might not be who you sent it to. Like it could be coming back from somebody else entirely. So if you only send it to one person, then you can identify it based on who you originally sent it to rather than who it comes back from, and therefore you'll know which one marked it as spam, okay? Or which one it bounced from, or whichever. So
What's your send interval out there?
what's my send interval?
Well, you're looking at a timestamp. So
How quickly am I sending messages, or how quickly
Yeah.
does it come back to me?
how quickly are you sending messages?
I can send 14 a second. So
So in other words, you could have 14 people. Well, they'd all have to bounce it at the same time.
but I would still know because it's a unique ID on each message, and as long as I'm only sending one message to one person, then I still have who I originally sent it to back here, right? So then it doesn't matter.
Bonuses for that.
What's that?
Said there's bonuses for that, sending one at a time.
Exactly. So then this is what happened. Is this a complaint, meaning somebody marked it spam, did it bounce, that sort of thing. And then bounce type, and to some degree bounce subtype, but that's usually pretty worthless, is will this keep happening? So if I sent this message again, is this going to happen again? If it's permanent, it will definitely happen again. If it is transient, then it may or may not happen again, like if it was a mailbox full message. As long as they go in and clean out their mailbox, it won't happen again. It's not necessarily a permanent failure. And then this little section here is whatever the server sent back as its error message. So this is just the raw message that came back. That can sometimes help you diagnose what's going on. So you definitely don't want to throw that kind of information away. So any questions so far? Pretty straightforward? Okay. So this is kind of a kind of bare bones bounce processing thing that I threw together for this slide because it fits all in one slide. It doesn't actually do anything, but it gives you the basic gist. So again, you get yourself the message, and in this case, I'm going to grab the header before I grab the body because you can actually determine what type of message this is from the header, just in case the JSON part is corrupt for any reason. And there are some other things which we won't get into of why you might want to do that. Anyway, so I'll grab it from the header, what type of message it was. So this is, again, whether it's a bounce or a complaint or whatever. And then I can go ahead and go through the verify routine. Again, we're going to check and make sure that Amazon actually sent this to us, not, Steve, because Steve's a dick like that. He does that sort of stuff. So, anyway, and then we're going to handle the subscription to SNS. So, like when we first set this endpoint up, we have to respond that we indeed can handle this. If not, the endpoint will go away. So once you have this code out on your server, you can then set up the endpoint, and it's going to go to whatever URL you post it to. So hopefully you can handle that at that point. And then we get the message, and we need to decode the message. Even though verify decoded the message, we're decoding the sub-message that is the actual notification of what happened. And if the notification type was complaint, that means somebody marked it spam, or a spam filter marked it spam, or whatever. So somehow it's spam. So then we do something like unsubscribe them from whatever it was they were subscribed to, so that we never send that message to that person again, so that they never have an opportunity to mark us as spam again. If it's a permanent bounce type, that's the really bad kind. Again, that's user doesn't exist or whatever. Then we want to stop sending that person emails altogether. So, for example, in the Game Crafter, in a user's profile, I actually have a flag where I can say, never send this person email ever again. And that way, it'll throw an exception anytime anything in the Game Crafter tries to generate a message to that person. So, the message will never go out.
Did the user ever see that flag?
Yeah, they can actually re-enable that flag themselves, should they change their email address or whatever. So, if I display that flag, then I also display some diagnostic information as to why that flag was switched in the first place. If they did it, or if it was switched because of a bounce or whatever. So, so then, yeah, so that's that. So you can also do some stuff like stop sending them messages for a timeout period if it was a transient bounce, for example. So I could say, all right, I'm going to stop sending them messages for the next 7 days. Give them time to log in and check their stuff. you might want to keep track of, did that happen a second time, and if so, maybe you don't send them email anymore. You could also, if you also should check for the last state, which is some unknown type of message came in. Because technically, there should only be 2 that we're checking for here. So if something else comes in, something bad happened. So any questions? That's kind of how bounce processing works.
So in your SES configuration, you're specifying an SNS configuration that where you pointed at the URL of your
That's right.
website.
Yep. So I go into SNS and I create a topic, or I go into SNS and I create a topic. So in my case, you saw there were 2 topics. There was SES and database swap were the 2 topics I created. And then you go back into SES and you say, point all bounce messages and complaint messages at this topic. And I could say point all receipt messages at this topic too, if I wanted to, or another topic. And then you go back into SNS and you configure the endpoint of, do I want to send out an SMS message, or do I want to post this to a web server, or, whatever it is that I might want to do. Does that make sense?
Yep.
So that's basically it. So any questions on any of that?
When something very bad happens,
Uh-huh.
do you notify something?
I actually just log it as a fatal in my system. I don't actually notify myself or anything because I don't actually care if it comes in, other than I might want it for diagnostic purposes later. So that's why I log it. But I don't actually want to go immediately work on that problem. So I have 2 minutes.
Somebody's pretending to be you.
Yeah.
So if you don't care about the email part, if you just want to build an app that wants to send notifications to your other app,
Yes.
what's the value in using SNS over just posting based onto your own server yourself?
Using SNS over versus just posting your, you mean directly from one service to another? The only advantage is if you like the breadboard-like configurability of, you don't have to configure anything in code. There's this user interface where you can go set up different endpoints, that sort of thing. It allows you to programmatically control things. Like, for example, I know some people that they use these as part of their notification system for their IT staff. So at different points of the day, the endpoint will switch to a different, it'll all be going to this one topic, but the endpoint will switch to a different person's SMS account. Does that make sense? So they actually have a program that'll go flip the bit in in Amazon. You could do that in your own code theoretically too. So it just depends on how much you want in your code versus you want out in this kind of third-party breadboard.
SNS will do other things beyond just pinging your server. It could send an SMS or.
That's right. Yep. It'll send an SMS or an email, or it will also post out to. Like if you have an iPhone app or an Android app, you can have it post a message out to that app as well. So it's just a push notification service.
Right.
It will push to lots of different types of endpoints, all the different types that they support.
Cool.
So, yeah. So in that way, you don't have to write any of those. You write, how do I post a message up to there, and it knows how to talk to all these other things.
Right.
So, anything else? If you're just going from your server to another server that you control, probably no point in going through that. So, unless you want that configurability for a future case. So, okay. So yeah. So then we'll move on to a little bit more description about kind of what my system is doing, so that maybe you get a better overview of the whole thing. So, in my little world, this is a simplified version of it, but in my world there is, we've got AWS, SNS, and SES. We've got my app that runs the web server, and we have the job server that does all kinds of background processing stuff at the Game Crafter, and then we have the user. So there's obviously a lot more components to this than this, but for the purposes of this discussion, we'll just limit it to those 5. So basically the user says, hey, send me an email. I like email. So they'll go into their user profile and say, yes, I want newsletters. And so that's going to be done over HTTPS. They're just in their web browser, fill out their profile. TGC app says, yay, we can send email to somebody. So when it comes time to sending email, we will send that out to the job server and say, hey, send out 45,000 emails at your leisure to our user base. Here's the list of users that want email. And so then the job server just knows how to send out emails to all those people based on this list of users. So the app server is free to do whatever it needs to do. And now the job server is doing all this stuff kind of asynchronously. And we're using Beanstalk. There's an app called Beanstalk D that we use for job processing. It's a C program. There's a Perl library for it and a bunch of other libraries for every other language you can think of. It's basically a memcache-like protocol that basically just allows you to throw jobs. And you could do the same kind of thing in like Redis or something like that, but Beanstalk is ridiculously efficient. It can do millions of jobs simultaneously. It was written for a site that had, I think it was 6 million jobs an hour is what it was processing. It was some sort of charity thing that was run on Facebook, so it had millions of users all doing stuff, and so it's designed for highly concurrent jobs. And it also, the thing I really like about it is that it has this really cool timing system built into it. So if you want to delay a job or make a job low priority or those kinds of things, it has little things in there to just do that. So I can say, I want you to send this email to this user, but wait 7 days before you do it, or whatever number of days or seconds or whatever. Or I want you to send 45,000 emails out, but I want to set the priority of that at the floor. So do everything else first, and if you got time, send out these 45,000 emails. Right? So those kinds of things, and all that functionality is built in without me having to write any of it. Whereas with Redis, you would have to write wrappers to do those sorts of things. So anyway, so we told the job server we're going to send these 45,000 emails. So it's going to go ahead and one at a time poke Amazon SES. Here's an email. Here's an email. Here's an email. Here's an email.
How fast is it? How long does it take to get through the 45,000?
I actually
Talking to Amazon SES.
A little over an hour? Or?
So I put a governor on it.
Yeah.
Right? So I have a 3-tiered governing system in it so that it cannot send more than 1,000 messages an hour.
Okay.
So
So that means it takes about 2 days.
So it takes two days to get through my particular list. What it is capable of doing is 14 emails a second, which comes out to like 3 hours.
Or so.
Yeah. So
Did you say 14 a second?
it's 14 a second. So it comes out to
send your
like.
whole thing in less than an hour.
Is it okay? Yeah.
So why is it that you stretch it out over 2 days?
So he doesn't get to be a spammer too often.
Maybe. That is part of it, but there's a couple things. One is that I want these to be kind of background jobs, so I don't want, even though this system is capable, Beanstalk is capable of having 6 million jobs in its memory at once. I have it on a little bitty server, so I don't want to run out of RAM because I need Beanstalk to work for other things too. So that's part of it, and part of it is also if I sent them out 1,000 at an hour. If something goes wrong, I can pause it, fix whatever's wrong, and then continue.
That makes sense.
And so, as it happened, when I first sent this out, there was something going wrong, and so I quickly paused it, fixed it, and went on my way.
You can pause just the email campaign and not all the other stuff?
Yeah,
Okay,
yeah.
that's cool.
Because, Beanstalk, you can totally control it. So what you do is Beanstalk has this notion of a buried job. So you bury it, and that means don't do this. Just, it's still in the queue, but you're not going to do anything with it until I kick that job. And so then it comes back to life and continues on where it was. So, so that's why I do that. So breaking it up into lots of little jobs over the course of a long period of time. As we go forward, I'll probably make it so that it'll do more than 1,000 at a time, but for this first campaign, because again, we hadn't done this, I didn't want to I wanted to be conservative about it.
Got it, so this is something you just started doing.
Yeah, this is, yeah, we've been sending emails via SES for a long time. I've not sent 45,000 at once before. So I just wanted to make sure that it was, yeah. Anyway, so we're pinging SES with each of the emails. It's going to then send it off to the user's email server. Here's the newsletter via SMTP, and then they, are going to get it and love it, hopefully, but probably some of them will say, this is spam. So that'll either come back via SMTP if it's a synchronous connection, or it'll come back via a web service, like if it's in Gmail, for example, and it wasn't the spam filter that did it, but the user actually marked it. So they get the message. Later they mark it. There will be a web service that comes from Gmail back to Amazon asynchronously later that says, hey, this user said this was spam. What are you going to do about it? At which point AWS will complain to SNS that I'm a jerk for sending spam and that I should stop doing that. And SNS will then point back at my server saying, hey, you're a jerk, stop doing that. And at that point, that's when I flag the user as unsubscribed from this particular list. Even though they didn't hit the unsubscribe link, they hit mark it as spam, but it's effectively the same thing. So
then question, what if an automatic spam filter catches it, perhaps unintentionally by the user, then what happens?
there's still, depending on the mail system, there still might be a trigger back to me saying it was marked as spam or not. Or it could just be that it is marked spam and I will never know that it was marked spam and the user will never have seen it.
Right.
So,
Okay.
which is more often the case if it's an
Right.
automatic. So,
But my thought is, or my question is, so if it's an automatic filter, then the user, if they're expecting it, might actually be able to check their spam box later on.
that's true, yes. In fact, there are many of our users that were upset that they did not get their message because some people had marked it spam, and as a result, some of the later people it auto filtered to spam, and then they were upset that they did not get the message. So they looked in their spam filter, and we told them to unmark it as spam and also add us to their address book so that it wouldn't go into spam in the future. And so, yeah, so we got it from both ends. Yeah.
Which is what happens when you do it.
That's right. Yeah. So anyway, that's basically the gist of how this works. So that's the whole process. If you wanted to see it all at once.
You never get credit for somebody having marked it as spam, then unmarking it.
I don't get a message back. I don't know if it gives it credit internally to their spam filtering system. I hope it does. I hope it does. But
there really isn't a good way for Gmail to tell Amazon that a user marked it as spam. There's a lot of unofficial ways of doing it, but there's no standard way of doing it.
no, they actually have a standard way between the two of them. They have a web service.
Right, just between them. But
Yeah.
if you're sending to joeschmo.org,
Oh, right.
you're not going to know that they marked it as spam.
Yeah.
That's true. Yes. Yeah. The big providers have a thing set up, but you're right. Your average server, you'd never know.
Right.
So.
Well, all right. So presumably you're sending to a lot of Gmail addresses.
Mm-hmm.
So a lot of the ones that are coming are from Gmail accounts.
Mm-hmm.
For whatever reason, hey, you're spam.
Yep.
Presumably a certain number of those users afterwards repent or figure out they actually asked for that or whatever,
Mm-hmm.
change their mind. You'll never hear that they changed their mind.
That's correct.
And they'll have been unsubscribed, presumably, so
Yes.
they won't get anything else.
Yeah. So we, between our system dealing with bounces and the people who actually hit the unsubscribe link and people who marked it spam, all that kind of stuff, we went from 44,581 messages that we sent, so 44,500 essentially, down to 42,982, so basically 43,000. So we dropped about 1,500 roughly users.
That would include other bounces too.
Yes. Again, bounces, marked it spam, or actually click the unsubscribe link as a result of that.
So that's about 3%, right? So it's not so bad.
No, it wasn't bad at all. We weren't sure what to expect since this is our first time doing it, and we've been collecting the "Do you want the newsletter" thing for 2 years, and hadn't actually sent out a newsletter. So we thought there might be more bounces from people like whose email addresses had changed or whatever. So yeah, overall I'm pretty happy with how that went. But yeah, that's that. And yeah, I don't know. Maybe there will be a future report on other cool things that I can do with this once I learn more. But this is what I know so far.
Could you now, during this, could you have it when they first sign up and say, click on email messages, then you send them a message and say, hey, put us in your address book?
That's actually not a bad idea. I could absolutely do that. So
Because that's what, now looking back over those 2 years, that's what you would have wanted to do.
Yeah.
'Cause as soon as they say they want it,
Put it in
send
the
something
address book.
which they're expecting right then.
yeah, that's not a bad idea. I should do that. Yeah, because that would prevent some of that stuff from happening. So anyway, yeah, I will do that. That was a good idea. Thank you. I don't actually participate much in newsletters, so I went based on knowledge that I could find online from like other services, and also from our marketing people who do lots of email campaigns. So that was kind of my, and then from what Amazon would tell me about stuff. So
Essentially, what you built is what the service that Constant Contact and MailChimp provides.
Yep.
The outbound processing and all that.
yep, that's it. And I built a user interface that's in our system, so that our people that are actually writing the newsletters can write them in our system, and then ultimately they display on our website too, so that people who don't subscribe to the newsletter but want to view it are actually in our website. They never leave our website to see it. That was one of the things our marketing people wanted, rather than redirecting them to some third-party site like Constant Contact to view the online version of this message. They wanted to be able to see it within our site.
Yeah.
So,
Sounds like you can do it a lot cheaper than Constant Contact then too.
oh God, yeah, yeah.
I know this because my wife has a business and she uses Constant Contact, and since long before I met her. So,
Yeah.
and it's very expensive for what you get.
Yeah, I want to say our marketing people said it was $1,500 a month for us to use Constant Contact because of the number of
That
users
sounds
that we have.
about right. Yeah.
So, and this cost us $1, other than my time to build it,
Right.
which is a one-time investment, which is a lot more than $1,500.
Right.
But it's a one-time
You will
investment.
make that up over.
Yeah, it took me about 4 days of actual development to build both the bounce processing thing and the user interface for actually building newsletters. So like, not a lot of time really. And then now it's in our system, so we don't have to synchronize anything back and forth, and it's all in line, and it costs us $1 to send, 45,000 messages.
And you have the added benefit of you've learned a whole new interesting system.
And I have learned a whole new interesting system, that's for sure. And actually, this is the bounce processing thing. Another reason we built this internally is because we wanted to start handling bounce processing anyway for our other things that send emails. For example, we have things that are called reminders. So if you have purchased a game, about 2 months later, we send you an email reminding you to write a review for that game. Or if you put something into your cart but didn't check out, about a week later we send you an email saying, hey, you have this thing in your cart, did you want to buy that? Those kind of things. So again, you can unsubscribe from those reminders, and we wanted to handle the bounce processing so that if it was bouncing or somebody marked it spam, they wouldn't get those anymore. So, anyway, so most of this 4 days of work was really reusable for all the other stuff that we're doing.
Right.
So many things that you work on, you integrate directly into Wing so that it's essentially built into your site. So is this also because it's so heavily interacting with Amazon?
This is not built into. I mean, this is built in Wing, but it's in the TGC. It's the TGC portion of Wing, not the open source portion of Wing. That said, if anybody actually wanted to use it, I would probably put it in the open source portion of Wing. I just couldn't put it in as. It would be a role that they could include if they wanted to use it, because you know, I don't want to assume. Wing does not assume that we will host it on Amazon. Wing assumes that it'll just be hosted wherever. So TGC is hosted on Amazon.
Yes.
So that's the thing. Like, we handle file uploading, for example, in Wing completely differently than TGC. TGC, everything goes to Amazon S3. Normal Wing uploads it directly to the file system of the server that you are on. So anyway, so we override that stuff for the TGC version of Wing. But anyway, so yeah, that's that. So all right.